For the first problem, we are trying to find acceleration and the reactions at A and B. So for the first part, I drew my free body diagrams of the forces and the mass and acceleration. For the x direction, I found that A equals P over M and then plugged that in and got 3.2. And then I did sum of moment about B and got it in terms of A, and then solved for A and got 3.82 in the upwards direction, and then I solved for the forces in the y direction to get 20.71 newtons in the upward direction. For the next problem, it is asking for the acceleration and the reactions at A and B, similar to the last one, but this time there are two semicircles that it's going along. Yeah, and the weight is 16 pounds and there's a velocity going in this direction. So for the acceleration, it's v squared over r, and that ends up being 150 inches per second squared. And then the acceleration is 15.5 feet per second squared. And solving this in terms of solving the general acceleration, you have to solve for this angle right here. So I did that using the inverse tangent or arctangent of an over at, and I got 24.14 degrees, and then solved for the hypotenuse and got 30.56 feet per second squared. The next part of the problem is to solve for the reactions. So I did the moment around A and the sum in the x directions, and got the reaction at B equals 1.285 and the reaction at A is 0.505. The next problem is asking for the angular acceleration and velocity at A and B for these two circles. And they are rotating. We were given the rotation at A and the mass of both, and that B starts at rest. Yeah, for A, we do the I equals 1/2 ma RA squared. And then we do the sum of forces and account for the friction factor. And then from the sum of the moments, we're able to find the angular acceleration. And then for part B, we do the same thing where we solve for I and then are able to find the reactions based, or the acceleration based on the sum of the moments. For part B of the problem, to solve for the angular velocities, we will set VC equals VC prime, and then we know that the time is 1.005 seconds, and then solve for the angular velocity with positive clockwise direction, get 25.15 radians per second, and then we do the same thing for B. And then for the next problem, we want to find the combined radius of gyration based on this diagram right here. I drew out my free body diagram kind of combined into the given, but this is the MA, so the motion part of the diagram. So this equals this, and then we solve for sum of forces in the y direction equals 5a due to this, and then we can find the acceleration, and then from there we can find the angular acceleration. For the next part, we do the moment about the center and can find that k equals 0.17059. For the next problem, it's asking to find the angular acceleration of the rod and the reaction at C. So we have these free body diagrams. We solve for I and have this equation for A. We solve for the moment about C, and then are able to find the angular acceleration from this equation right here. And then for part B, we do the sum of forces of the y and x direction. And since these are all known, we're able to find cy and then cx. The next problem, we want to derive an expression for acceleration of the center of the wheel in terms of r, k, beta, and g. We do I alpha equals mk squared times alpha, which can be simplified, and then you take the sum of the moments about c, with clockwise being positive, plug in all of those numbers from the free body diagram, and get that a equals r alpha squared, or sorry, acceleration equals radius times angular acceleration, and get this general equation. So I guess you can kind of ignore this part. The next problem, we are trying to determine whether the disk will slide, and the angular acceleration and the of the disk and the acceleration at g. So to determine if the disk slide, we first assume that the disk will slide, and solve for the friction, I guess the friction forces, assuming that it will slide. So we solve for I, and then moment about c in the counterclockwise direction, solve for the angular acceleration, and then the acceleration and sum of the forces in the y and x directions. And since this is a positive number, we know that the disk will slide. The next part of the problem, since we know that f is greater than fm prime, we can use the f equals the friction factor of kinetic friction, or nu k times n equals 0.2 times 5, which is 1 pound, and then solve for the sum of the forces in the around, I guess, S. I don't know. I think that might be supposed to be G, but and then we get alpha equals 12.88 radians per second squared in the counterclockwise direction, and then do the sum of the forces in the x direction to solve for the acceleration. The next problem, we separate into two different, or I guess technically three different parts. So we have two disks that are connected by a rod. For the first part, here's my free body diagram for the disk A. We want to find the acceleration at A and B, which are the same, and then Fx, so the horizontal force on B by D, with these knowns on the right, or givens. And for the solution, we know that I equals 1/2 mr squared, and the sum of the moment in the about E in the counterclockwise direction is positive. We have all these knowns except for C and K, M, and alpha. So this is kind of like leaving in the general equation, or general form of the equation, so we can plug them into each other. We do the same thing for B, and then we solve or write an equation for the sum of forces in the x direction, with the positive direction being to the left, and then we're able to plug those equations back into each other right here, and get that the alpha equals 21.97 radians per second squared in the counterclockwise direction. And then for A, we know that A equals r alpha, which is 0.12 times 21.97, which is 2.64 meters per second squared. And we know that the horizontal forces is going to be D equals 0.0432 divided by 0.008 times 21.97, which is 11.87 newtons.